Hello everyone, let's walk through this physics challenge on the board. A stretched string has a mass per unit length of 5.0 grams per centimeter and a tension of 10 Newton. A sinusoidal wave on this string has an amplitude of 0.12 millimeters and a frequency of 100 Hz and is traveling in the negative direction of x. Write an equation for this wave. Okay, now we have a two-in-one question, because why I said it's a two-in-one question is that now let's look at this statement. A stretched string has a mass per unit length of 5.0 grams per centimeter and a tension of 10 Newton. So in this case, this is when we talk about this. In this case, we are going to calculate the speed of the what? Stretched string, which is speed of transverse wave. Okay, because a transverse wave is a wave, okay, whose vibration of the particles of the medium about a mean of fixed position is perpendicular to the direction of propagation of the wave. Okay, and why I said this is a two-in-one question is that we need to understand what to do here. Then every other thing we have here, of course, we already know what this is going to be. When writing the equation for the wave. Okay, like I said, for a stretched string having a mass per unit length of 5.0 grams per centimeter and a tensional force, that is a tension of 10 Newton. So it means that we're going to use the formula for calculating speed of transverse wave. Because for transverse wave, you have V to be equals to square root of tension divided by mass per unit length, also known as linear density. Then also, it depends on the question. So we also have what we call speed of mechanical wave. There's also what we call speed of mechanical wave. Speed of mechanical wave is when we have V equals to square root of KL divided by mass per unit length, where K is a spring's constant. Then also, there's also what we call speed of electromagnetic wave. Speed of electromagnetic wave. And because we know that all electromagnetic wave can travel at the speed of light, so speed of light, okay, is equals to the square root of the product of permittivity of free space and permeability of free space. So, like I said, we're going to make use of V equals to square root of T divided by mass per unit length to calculate the speed of wave generated in the what? Stretched string. Okay, so now according to the question, we are giving mass per unit length. We are giving the mass per unit length. This is the mass per unit length. Okay, so the mass per unit length is given to be 5.0 grams per centimeter. And we know that all units must be converted into what? SI units. So I'm going to convert this to kilogram per meter. So to convert this to kilogram per meter, so mass per unit length will be 5 divided by 1000, okay? That is 5.0 grams divided by 1000 multiplied by 1 kilogram divided by grams all over. Then to change 1 centimeter to meter. So 1 centimeter, okay, to meter. I'm going to multiply this by 1 meter over 100 centimeters. Okay, so that this will be, we're going to have mass per unit length to be 0.005, because 5 divided by 1000 is 0.005. So grams, we cancel grams, okay, then divided by, this is 1 over 100, 1 over 100, okay, so this is in kilograms, while this is in meters. So the mass per unit length will be 0.005 multiplied by 100. So now the unit will be kilograms per meters, and we're going to have this to be 0.5 kilograms per meter as the linear density. Okay, so like I said, because we have the tension, the unit is in SI units, so that's why it's important to convert all units into what? SI unit. That is, SI unit is when we have the unit of mass in kilogram and that of length in what? Meters. So now, speed of wave is equals to square root of t over mass per unit length. So that this will be square root of 10 divided by 0.5. So that v will be equals to square root of 10 multiplied by 2 because 0.5 is 1/2. So that this will be v equals to 2 root 5 meters per second. So the speed of wave generated by the stretched string is 2 root 5 meters per second. Okay, now a sinusoidal wave on this string has an amplitude of 0.12 millimeters. So we have the amplitude, okay, this is the amplitude, okay, the amplitude is equals to 0.12 millimeters, which we can convert into meters, okay? 0.12 times 10 raised to the power of minus 3. And this is same as 1.2 times 10 raised to the power of minus 4 meters. So this is the amplitude. Let me box this, amplitude. And we are given the frequency. Frequency, F is equals to frequency. The frequency is 100 hertz. The frequency is 100 hertz. So what to do from here is we know that for a wave traveling in the negative direction of x, omega t in the general equation will take a positive sign. That is because the wave is shifting in opposite direction of the x-axis. So to write the equation, okay, we know that the equation of a sinusoidal wave, the equation of a sinusoidal wave, okay, is we have that to be y as a function of distance x and time t to be equals to amplitude sine, we have kx minus wt. But in this case, we want to write the equation of a sinusoidal wave traveling in the negative direction of x. So this will be positive. Okay, so now we need to calculate, we need to know what is the value of the wave number and also omega, which is angular frequency. And this is the wave number. So, and we know that k is equals to 2 pi over lambda. So we need to know the value of wavelength. So to calculate the value of wavelength, so we have the velocity and frequency. Okay, and then we know that, so to calculate, let's do this way, to calculate lambda, lambda is equals to v over f. You know, from v equals to f lambda. So v and lambda will be equals to v over f. So that lambda will be equals to 2 root 5 divided by 100. 2 root 5 divided by 100. Okay, 2 root 5 divided by 100. Okay, so that this will be lambda will be equals to root 5 over 50. So the unit of wavelength is the meters. The unit of wavelength is in meters. I don't want to change, I don't want to convert this and that into decimals. Okay, so that's wavelength. So that the wave constant, that's k, which is equals to 2 pi over lambda, will now be k equals to 2 pi divided by root 5 over 50. And this will be k equals to 2 pi multiplied by 50 over root 5. Then k will be equals to 100 pi. over root 5. Okay, 100 pi over root 5. Now, in this case, I'll need to rationalize this, okay, so that we can have, that is multiplying 10 pi, 100 pi by root 5 over root 5. Then k will be root 5 times 100. That will be 100 root 5, then times pi. 100 root 5 pi. Then root 5 times root 5. This will be 5. So that 100 divided by 5, that will be 20. So we have 20 root 5 pi. So this is in radians per meters. So this is the wave number, okay? 20 pi root 5 radians per meters is the wave number. Then also we need W, which is omega, okay? W is 2 pi f, and that will be W equals to 2 pi multiplied by 100, and this will be 200 pi radians per second. The unit of angular frequency is the radians per second. So this is the angular frequency. Now, to write the equation, okay, we want to write the equation, that's equation in this form. So we're going to plug in the value of amplitude, which is this guy, and also the value of k, and also the value of w. So the equation will be y as a function of distance x and time t equals to 1.2 times 10 raised to the power of minus 4. Okay, then sine parenthesis k is 20 pi root 5. Okay, then x according to the equation, then plus w, which is 200 pi, okay, then times t. Okay, so now let me factor out 20 pi in this case, so that we can have the equation to be y as a function of distance x and time t equals to 1.2 times 10 raised to the power of minus 4 sine 20 pi parenthesis root 5 x plus 10t. So this is the equation of a sinusoidal wave, okay, traveling in the negative direction of x, having a speed of 2 root 5 meters per second, frequency of traveling with a speed of 2 root 5 meters per second, frequency of 100 hertz, and amplitude of 0.12 millimeters. The noblest pleasure is the joy of understanding. Bye-bye.